Hello everyone, welcome to another video. So today we're going to start our journey to settle vectors. This will be our last chapter in Sec 4. So you can see that in this video we're going to cover the bulk of these two parts. So we're going to learn what is a vector, how to find magnitude, how to plus and minus vectors, how to multiply a number to a vector, and what these two means visually. We're going to learn this thing called resultant factor, which is absolutely crucial. This is our key skill 1. And then with this, we extend to these two little laws here, and that's more or less for this video. So let's start proper. So what is a vector? So exactly what is a vector first? We call it column vector because the vectors looks like this. It's in a column, so it's up and down. Okay, so it represents a direction in terms of x and y. So you can see that this is a vector PQ. It starts from P to Q. See, there's an arrow here that points in this direction, right? So this direction. So we can call it PQ. We can always call it A with the little tail below. So it depends on how you want to describe the vector. It's up to you. So in this case, you can see that our vector PQ is 4, 3. So this number here means is the x value. So it's a positive. That means I'm going to the right side by 4 units because this direction is positive. And then of course y is also positive, so I'm going up 3 units. So from P to Q is 1, 2, 3, 4, x-axis 4 units, 1, 2, 3, y-axis 3 units. So that's what the vector is trying to represent. Okay, a direction with a certain magnitude. So magnitude means how far this is traveling. So it's basically the length. So how we do the length is basically because these two are x and y, so this is right angle. So a right angle triangle, I have these two. I'm going to find this is Pythagoras Theorem. So it's square root of this square plus this square, which is over here. Okay, so you can see that that's basically what vectors is. It is a direction that has a certain length. So in this case, you can see that I have another vector QP, which is -4, -3. So in this case, it is basically the opposite way. So it's from Q to P. That's why it is 1, 2, 3, 4 to the left because it's -4. And you go down 1, 2, 3 because it's -3. So that's what vectors is. Okay, so the next part will be this very important concept called eventually we're going to reach resultant vectors. And of course there's going to be a QR code here. You need to scan this and watch yourself. This is the most important part of this whole chapter. You need to get this right. Okay, so you can scan yourself. I'm going to continue with the next example, so come back when you have watched the QR code. Okay, so in this question we're going to do some simple things. So these two vectors, I want to find magnitude. So it's this square, see these two add together, square root. So this is our Pythagoras theorem, and you can see that I write these two lines here. It represents magnitude. So this is the same thing. I'm going to do the same. Done. Okay, so for the next question, it's a bit more difficult. They tell you this is the vector. There's a p here that's unknown, and then they say that the magnitude is 13 units. So I start with what they give me. The magnitude is 13. So PQ is 5 and P, right? So it's -5 square, P square, add together, square root equal to 13 here, 13. So and then I need to solve for P, right? So the P is stuck in the square root, so I'm going to square both sides. So 13 square is this one. Here no more square root. 25 minus over, I got 144, and I'm just going to square root both sides, so it's plus minus 12. So that's how you do it. So for the next one, I have P and I have Q. Now I want to find -2 times P minus 4 times Q. So literally you just write down exactly that. So -2 times P and -4 times Q. And then the 2, when you multiply, going to multiply to both numbers, right? So it's -4 minus 4. So it's -8 minus 6 plus 16, so it's 10. And that's it. So this is the vector. And then to find the magnitude, I'm going to find the magnitude of this one. So it's -8 square, 10 square, -8 square, 10 square, plus together, square root, done. Okay, so this will be a bit more difficult. So they say this minus this equal to this. So what they are trying to make you do is actually you need to solve simultaneously, because if you compare all the x value 2a minus 3b is equal to minus 5. So that's our first equation. Now similarly, using the y, you do the same thing. So minus b minus 5a equal to minus 13. So here. And with this, you go and solve the simultaneous equation yourself. So this is not Sec 2, so I'm not going through. Okay, so the last part of this video, we're going to talk about a resultant factor. We learned that before. It is key skill 1, right? So we're going to use the same concept and extend into this thing called triangle rule. It's actually the same thing. It's just a fanciful name because it evolves as a triangle. So in this case, you can see that I have a vector here called a plus b. So it's from here to here. So from this point, I travel this point is a plus b. So where did this come from? Actually, it comes from here. I'm going a first, then I'm going b. So if I plus these two together, the resultant factor is just a plus b. So this forms a nice triangle. And as you know, in math, many questions are going to have some triangle somewhere. So that's where this rule becomes relevant. So in this case, if you look at just the example for here, a is 2, 3 here. B is 1, 2, 3, 4. Then 1, 2, 3, 4, 5. That's why it's 4 minus 5. If you add it together, you get 6 minus 2. If you look at this red vector purely by itself, it's also 1, 2, 3, 4, 5, 6, then 1, 2. See, it's exactly the same vector. So that's what the triangle rule is all about. Now, similarly, for the parallelogram rule, it's the same. The theory is this: A plus b is going to give you the center line, which is a plus b. Now this looks not very intuitive, but this is a parallelogram, right? So if this is a, this is b, if you know parallelogram, this direction is also b, because this and this is the same. So actually it's just a plus b is equal to this line, which is this vector, which is a plus b. So it's the same thing, right? So this is just a visual example. So you can see that in this case, my a plus b is still 6 minus 2. That's all. So these two rules is just a convenient thing. The crux of this thing is still the resultant vector, which you already learned, key skill 1. Okay, so I'm going to pause here. So this will be the end of the first video. I'll see you in this next video. So hope you learned something. Thank you and bye-bye.